One more thing we want to worry about for section 5.4 is the idea of congruent triangles. We know that two triangles are congruent if one, corresponding angles are equal, and two, corresponding sides are equal. So we notice that congruent is a more strict condition than similar. So we notice your textbook uses a slightly more liberal definition of equality. We notice that we technically should say angle measures are equal and should say side lengths are equal, but for general purposes, for everyday purposes, saying the sides are equal, saying the angles are equal is sufficient. We don't need to get too picky. And so we notice that, again, the configuration doesn't matter over much. We notice if we have one triangle is 5, 5, 3, 4, and the other triangle is 5, 3, 4. We notice that the fact that they're rotated around doesn't matter. They're still going to be congruent because they have the same side lengths. At least they're supposed to. Again, the drawings will not always be perfectly to scale. And then we actually notice, so we notice that, let's just call these A, B, C. So we have to be careful. We notice that if we say ABC, we notice we're going to say we could say the other triangle might be, what do we want it to be? We'll call that D, E, F. And so we know that, again, we have to be careful, triangle ABC, and now we use this equal symbol with a squiggle over it to indicate congruence. Triangle ABC is congruent to triangle DEF, and we notice that AB equals DE, BC equals EF, and AC equals FDF. And so we have to make sure that that order is correct. If we have the order off, that will throw things off. So we also notice that if we had two angles, if we know that one angle is 40 degrees, the other angle is 60 degrees, the third angle would have to, well, we don't actually need to know the third angle. If the other triangle was 40, 60, we know that the third angle has to be 80, and so we know the two triangles must be congruent. Well, actually we have to be careful. We also need to know that the side lengths match. So we also need to know that, let's call this side length A, B, C. We need to know that 80 degrees matches with side length A, the 40 degrees matches with side length C, and the 60 degrees matches with side length B. So if the three sides match, that's sufficient to get congruence. Having just the three angles matching is not sufficient. So in this case, you notice that angle, angle, angle is sufficient for similar. It's sufficient to show similar triangles. But not congruent. And so what we'll actually notice is we want to know what is sufficient to show that the triangles are congruent. Criteria for triangle congruence we have side, side, side that we just saw. Side, side, side. All corresponding sides are equal. Case 2 is angle, side, angle. Oops. So ASA, this is angle, side, angle. We notice if two angles are the same measure, the same, are equal, and the included side are equal, then the triangles are congruent. So we'll notice that we'll often write that as little markings. So if we knew that this was triangle A, B, C, D, E, F, and we said that we'll use this little mark, so that single line through side A, B, and that single line through side D, E, tells us that AB, the line through, so the tick mark, the short line through AB and DE indicates that AB equals DE. And similarly, if we draw little arcs at the angles, that indicates that the arcs at the angles indicate that angle A, angle A, angle A equals angle D, and angle B equals angle E. And our third way of doing it is, that was angle, side, angle. Our third way of doing it is with side, angle, side. And we talked about this a little bit. We notice that here we're just saying that if yeah, sorry about that. Technical glitch. If two pairs of corresponding sides are equal, and with the included angle are equal, then the triangles are congruent. And so visually we see that in this case we would have, we'll stick with triangle ABC, DEF. We'd say that side angle side is telling us if AB is congruent to DE and AC is congruent to DF, and that included angle A is congruent to angle D, then the triangles are congruent. So if AB equals DE, AC equals DF, and angle A equals angle D, then triangle ABC is congruent to triangle DEF. So you notice the whole thing is very visual. So we notice that angle side also works, but only because it forces angle side angle. You notice side angle is not at all reliable. It generally doesn't work. Because if we have two sides and an angle that isn't included, we notice that there are lots of ways to get that same configuration. In particular, at least two. So if we had so let's draw it this way. If we had ABC and DEF, it's pretty easy to see that we can make we can make AB. It's easy to make AB equal to DE, AC equal to DF, AC equal to DF, and angle B equal to angle E. But we can see pretty clearly that they're not the same triangle. They're obviously not congruent. So side angle does not work. And so a typical kind of question would be to just be given two triangles, and you could be given little marks, and you could ask, are those triangles congruent? Are the triangles congruent? And why? And so we notice that we've got side angle side, so that we've got two pairs of corresponding equal sides, and the included angle is equal, and so we notice that they're congruent by side angle side. And if we had two triangles like this, and we knew notice the tick marks, we've got two angles congruent, two pairs of angles are congruent, and an included side is congruent, and so we notice that these two are congruent by angle side angle. And then it shouldn't be terribly shocking that if you saw two triangles and you had markings that indicated that all three sides were congruent. We know this is congruent by side, side, side. And what's kind of interesting about these is that we can justify all of this using trigonometry. And we might talk about that a little bit in a later chapter. I'm not quite ready for that just yet.